The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody, and welcome along to DBA Fundamentals Down Under. My name is Warwick Rudd, and once again, I'm your host for this session today. In today's session, we've got Ben Miller talking to us about SQL Server Encryption. Now, I will hand over to Ben shortly, but before I do, I've just got a little bit of housekeeping that I want to run through with you. So I just want to give a call out to our upcoming SQL Saturday event here in Brisbane on May 28th. If you haven't registered already, there's still time to register to learn from some great local, interstate and international speakers for this event. We also have a pre-con on Friday the 27th on Power BI with Reza Rad. Registrations for that are still open as well. So we can see on the link below, available to register for the pre-con on Eventbrite. Hopefully I'll see you on the Saturday. Now, next month in June, we've got SQL Server Database Administration for the non-DBA by Denny Cherry. Registrations for this session are open, so I look forward to seeing you all next month when we kick off that session. So without further ado, I'll hand over to Ben to take us through today's session.
Thanks, Warwick. Let's go to the slide deck first. And during the presentation, feel free to ask questions, and I'm not sure how you do that, but I'm sure you guys do know how to do that. So today's session will be talking about TDE and SQL Server Encryption. So the majority of the information that we'll give will be about SQL Server TDE, but there is some encryption things that you'll want to know, and we'll cover those in the slide deck, such as SQL Server Backup Encryption that was introduced in 2014 and how you accomplish that. And then we'll also talk about Asymmetric Keys in using cell encryption as well. So let's get started. This is a slide that you'll get, the slide deck, and so this is me. I'm not going to belabor this slide. We're going to jump right into the content. So here's what we're going to cover. It looks like a lot, but it actually goes pretty quickly. There is a majority of this presentation that will be demo, just so you can see the interactions with SQL Server keys and encryption. So we'll talk about the encryption hierarchy, as that is one of the most important things you can learn, especially when you want to encrypt anything. If you establish the encryption hierarchy and keep it in place, you can use encryption anywhere you want inside SQL Server, including using symmetric keys to encrypt a piece of data, either a variable or just data, or data in a column, or using symmetric keys to encrypt more things. And then we're going to talk about certificates. Certificates and keys are part of the encryption hierarchy. As you learn the encryption hierarchy, you'll see the keys and the certificates interact with each other. They are the building blocks to get to TDE. The next part we'll talk about is how to finally encrypt a database using a new as of TDE keywords as you create a database encryption key. Then we'll touch on encrypted backup and talk about cell level encryption, and that should take us up through the majority of the time. So let's talk about the encryption hierarchy. The first part of the encryption hierarchy, when you think about SQL Server encryption, is Windows. So we know that SQL Server, and that's going to change soon, we all know that SQL Server will eventually be able to live on Linux as well. But for those on the Windows platform for now, there are two pieces that get installed or instantiated when you install SQL Server. The first one is in the Windows operating system level. There's a API called the Data Protection API. You'll hear it called DP API. That's very common out there. It's been around since Windows Server inception. But basically it takes components of the Windows operating system and uses those to encrypt things. The reason why that's important is because if you were to take the encrypted item off of that machine, it could not be decrypted. So it's kind of a physical premise thing where You live on the OS, and the OS governs the encryption. If you remove the thing from the OS, like a drive or something you've encrypted, it will no longer be able to be unencrypted unless it's back in the same place it started. So the thing to remember about that is that whenever you, those of you who have changed like CPU or added a CPU or done enough to the operating system to change it, you have to reactivate Windows. Same concept applies to the encryption side of OS. Once we have DBA in place, because Windows is installed, SQL Server gets installed, and the first thing it does is it creates a service master key that is used as the base of SQL Server encryption. This service master key is encrypted by DBAPI. So the beginning of the encryption hierarchy is Windows. The next part is the SQL Server instance, where it creates a service master key, and that plays into the account that starts SQL Server. So the SQL Server startup account is a player in this service master key getting encrypted as well. And we'll talk about that in a moment. But once the service master key is created, it is used from the rest of the hierarchy. It is all done through the service master key. At the level that you now have SQL Server installed, you now have the database called master. Master, obviously, if master does not load in SQL Server, the SQL Server doesn't load and it stops. So the next level in the hierarchy is a database master key that lives in the master database. And the most important thing you can remember in this part is that the master database is the underlying piece of the database encryption hierarchy. Because master always has to start up, that's where it looks to be to get the master key. The other thing to know is that master database cannot be encrypted for this reason. If it had to decrypt the master database to get to the key to decrypt your database, it would be very problematic. So the master key is created. Once you have the master key created in the master database, you must create a certificate in the master database. This certificate does not have to be created from a outside source. Many of you will probably know that when you go to a web page and you use SSL, that too is a certificate. The reason why this is important to use a certificate is because it has two pieces to the certificate. It has a public key and a private key. The public key is one that is accessible to the public and can be distributed. The private key is what actually protects the data below it. Now the next piece in the encryption hierarchy is finally the new keywords of database encryption key. Now the thing to remember is the database encryption key goes in the user database. So everything we've talked about above this, the service master key is created by the service, the database master key is created in the master database, and the certificate is created in the master database. The database encryption key is created in the user database and lives in the boot page of the database. So when you boot up the database, it loads that only if the encryption hierarchy above is in place. So if you removed any piece of this in the middle, you would not be able to encrypt the database. This is the new graphic. So if you notice, this graphic I showed you before said SQL 2008. And that is because it's the simplest encryption hierarchy diagram I could show that would illustrate the things you do. But Microsoft has created a new one. This is the 2012 version. It shows a little bit more detail in here. One, that you'll see the passwords, the PWs. You can create each piece of the encryption pieces, the database master keys or the symmetric or asymmetric keys, with passwords. They're not as secure because it has to use a different algorithm. We'll talk about that in a moment. But everywhere you can see a password, and there's one thing in the middle, the little gray EKM module. We'll talk a little bit about that, but not much, because I don't have an enterprise key management system installed, so I can't really show it to you. but it is basically enterprise key management, which allows you to keep your keys outside of SQL Server. And today there's a new Azure Key Vault that is in Azure, Windows Azure, that allows, Windows Azure, that allows you to keep your keys in Azure Key Vault and use them in encryption. So, and I have not set one up yet, so I cannot demo that. But that's a way to keep the keys outside of SQL Server. So if your SQL Server was damaged or you couldn't get to the backup of master, you could still take care of your EKM, your keys inside EKM. So let's talk about the keys now, so we can get an understanding of how they work. This slide is very busy, and I put it in here not to talk about all of it. So we are not going to belabor all of this stuff because you can read for yourself. The key points that I want to illustrate is that RC4 is a dead algorithm, and you should not use them. RC4 has been cracked, and it's still in there for backward compatibility. But in new installations and even in existing installations, you should look to re-encrypt with a stronger or a different key. So RC4 is not to be done. Whenever you create a symmetric key with a password, it is limited in the encryption algorithm it can use. So you look at the three bullets that talk about symmetric keys created. With a password, they're always created with triple DES, which is strong, but it's not as strong. Any key that you create that is triple DES in encryption, it uses 192-bit key. If you use the triple DES 3 key, I'm sorry, it uses a 192-bit key, and the triple DES uses the 128-bit key. So they're not as strong, but they're still strong. So you're welcome to still use a password. The key point of this slide is that whenever you use a symmetric key, you have to open the key in order to use it. So if you use a password to create the symmetric key and you intend to encrypt a cell or encrypt a piece of data, you must open that key. So that means you have to expose your password to that key in order to use it. So if you have a function, or actually you can't use a symmetric key in a function, which I actually should add to this slide. It came up in the last presentation. But whenever you use the symmetric key in a stored procedure to decrypt and encrypt data, you must expose your password by opening the key. Whenever you have the encryption hierarchy in place, you don't have a password on the database key. You don't have to have a password on the symmetric key as long as you have the database master key, a master key in the database. And we can show you that here. I have a demo that shows all of the encryption by cell. So we'll just leave it at that. The permissions on the bottom are for you to review. You do require certain permissions in order to create one, in order to use one, in order to be able to encrypt things with certificates and asymmetric keys. So this is for your reference. Asymmetric keys are a little slower. So as we talked about on the symmetric keys, they are the fastest keys that exist inside SQL Server for encryption. Asymmetric keys simply means that there are a key pair instead of one key. So you can kind of think of it like a certificate. So if you were to think about the speed at which it encrypts, you could believe that the symmetric key is faster, the certificate is next fastest, and the asymmetric key is the next fastest, or being the slowest. This is a key pair that is encrypted by a master key or a password, and it can actually be, in this case, encrypted by the EKM provider. The symmetric keys are not that way. The algorithms, if you look down on the third bullet, that can be the RCA 512, so that's 512 bits, and the 1024 and 2048. These are more akin to what we see in SSL. SSL used to be that 1024 was very, very strong. Now we're starting to see 2048-bit encryption on SSL. that is a very hard algorithm to crack because of the number of bits. The problem is that the higher the bit length, the slower you go. So one last point on the asymmetric key is the first bullet that just illustrates that there are certain elements or objects inside SQL Server that can own an asymmetric key, and that is the Windows logins, the SQL Server logins, and the application role. Those are the only things that can own it. So groups and normal database roles, you cannot own, those cannot own asymmetric keys. So you must assign or create them as a Windows login, server login, or as an application role. And again, this slide has permissions on what you need to have in order to use these keys. Now we're going to talk about the database encryption key. This is a special key. The keyword is database encryption key. The reality is still a symmetric key. It is a special symmetric key that when you use the keywords database encryption key in the create statement, it puts that key in the boot page of the database. When the database engine starts up, the master key is loaded, the certificate is loaded, and then when it goes to load that database, it will look in the boot page. If the encryption hierarchy is in place, then the database will be able to be decrypted and data can start flowing into the buffer pool. If it cannot be decrypted, then it will stay offline. It won't allow you to open that database. Now, the other thing I'm going to talk about here really quick is the idea of using keys to encrypt data. Now, you could choose to encrypt data and store it in any various ways. But typically, if you were to encrypt a column, say you have a database with social security numbers or credit cards or the birth dates or things that you would want not to be decrypted so that if anyone got your backup, it would be useless to them. The one thing that I recommend learning about is how to salt your database. And no, I'm not talking about the salt that you would eat on the table, at the table with pepper, but salt in the concept of an added value that you would add to the value you're encrypting, and then that would make that value random. If I had the same credit card number in the database 17 times, and I used a different salt value for each one of those 17, those credit card numbers would now be unique. And that replaces the idea that the most important thing for a hacker is to get the best surface area he can if he's going to decrypt. So the idea of a salt is that you would generate a random number or a random piece of data that is not duplicated in your database, and you would add that salt to the value, and you would then encrypt the value and store the salt. It doesn't have to be in the same table. It can be in another table, but it has to reference that key, because in order to decrypt that value, you would need to add the salt to, or compare the value. You'd have to add the salt to the value you're comparing with and then encrypt to compare. So just know that the salt makes the data unique. When you decrypted that value, you would have the data value plus the salt. If you don't store the salt, you won't know what to take away from that value in order to get your original value. So salting becomes important. It's really not the premise of this talk, but I wanted to make sure that if you were thinking about cell encryption, you would want to think about salting your data as well, not just encrypting the data and putting it in the database, especially for data that is duplicated potentially. Now let's talk about the certificates for a moment, because the certificate is the piece that is directly above the database encryption key in the encryption hierarchy, and therefore if you lose that piece, you have a problem. Now the way certificates work in SQL Server is it does adhere to the PKI scenario with a public key and a private key. That's normal. Like I said, you could get a key from VeriSign or Komodo or anybody else, and you could buy a certificate, and that certificate is a completely valid certificate as well. So if you wanted that key or that certificate to be managed by a third party, you could then go about it that way. You could have your own certificate server in Windows, or your own version of certificate server from another vendor that you've purchased to issue certificates for your organization. You can do that because it's just a certificate. It has a public and a private key. Now, inside SQL Server, you're allowed to create a self-signed certificate with the keywords create certificate. When you do that, SQL Server only requires two things to create it. One is the subject, which would just be a text, and I'll show you more in the demo, and a name that will be stored as the name of the certificate in sys.certificates. Those are the only two things that are required by SQL to create a self-signed one. Now, the expiry date is a required field in a certificate, but SQL Server defaults that value, so you don't have to specify it if you don't want to. The default value is 1 year from creation. The key here is that in an SSL scenario, you end up with ideas of the expiry date in an SSL scenario. If it expires, it's no longer valid. The SSL certificate is meant to validate that website as being certifiable, or that it's valid and you can trust them. Inside a self-signed certificate, you don't have a trail that leads up to the root certificate. So the expiry date is actually ignored by TDE. So you could create a certificate and it would expire a year from today. A year from today, TDE would still continue to work. The reason is because SQL Server does not check for revocation of that certificate, where SSL does. So I typically will create a certificate and I will put the expiry date 20 years in the future, just for sake of in case there is a reason why an expiry date is required. I don't want to have to alter the certificate or create a new one and re-encrypt. That's completely policy driven inside your own company, inside your own uses. You can do whatever you want there, but know that it's ignored by TD and it's not Now, a certificate doesn't only get used for TDE. It actually can be used for encryption of a cell as well. I mentioned that inside a function, you cannot use a symmetric key, and that is because the open symmetric key keywords are not allowed in functions. So you could use a certificate, which you don't create with a password, but they have encrypt by cert and decrypt by cert functions that allow you to use a certificate to encrypt or decrypt. It is slower, but it does give you the use of functions rather than using stored procs. So it's one of those important things. Now, the other thing I can't underscore enough: on any type of certificate or key or anything that is a secret inside SQL Server, you want to ensure that you have backups. Just like your data is important, your certificates and encryption hierarchy is very important as well. If you don't keep a backup and you lose that certificate, there is nobody that can decrypt your database. And that's just the way it is. So if you had your database and you detached your database or decrypted it, or had it encrypted and you lost that database and you needed to get a backup restored and you lost your certificate, you would not be able to restore that backup. So backups of certificates and keys are very, very important in this encryption. So let's talk about TDE specifically. Now, TDE takes advantage of the entire encryption hierarchy, and when it's in place, it works very well. The TDE stands for Transparent Data Encryption, which means that the database is encrypted on the disk, or as they call it, at rest. The database files are encrypted as they get hardened to the disk. Everything that's in the buffer pool is all decrypted, and that is where the layer of the encryption comes in place. If the encryption hierarchy is not in place, the database cannot start up and start reading data into the buffer pool for that database. Now, with the encryption hierarchy in place, you have these options for for encryption algorithms. When you create your database encryption key, that's where you use the algorithm, and you'll see that more in the demo. But AES 128, 192, and 256, and triple DES 3 key. Those are the encryption algorithms that are allowed inside TDE. Now, I have not checked 2016 to see if they've added new algorithms. I don't believe they have, but that's something that you can check out as the SQL Server 2016 releases June 1st. Now, the encryption is performed at the page level, which means that as the pages get read from the disk, they are decrypted, put in buffer pool, and as you change or add data, it gets hardened to the log, and the log files are encrypted and eventually end up in the data files. So the log files are encrypted and the data files are encrypted whenever you encrypt a database. The one database that gets encrypted by default automatically is TempDB. So when one database is encrypted on your server, TempDB just gets encrypted by default. And there's nothing you can do to stop it, actually, because TempDB is a shared database, and that can be a good thing or a bad thing, but everything that goes through TempDB must be encrypted to preserve the integrity of the encryption in the one database that is encrypted. Now, when you have a database that's encrypted, know that if you use file stream data, it is not encrypted when TDE is enabled. And that is because file stream data, by virtue of what it is stored outside the SQL Server engine and stored in the file system. The file system is not controlled by SQL Server, only kept track of by SQL Server. So it does not have the ability to use file stream data. The other reason file stream data cannot be encrypted is because file stream allows you to Win32 file stream the data outside of SQL Server straight to the client using Win32 file streaming. There's no way that the Win32 file streaming protocol could ever decrypt that data without a connection into SQL Server. So therefore, file stream cannot be encrypted. The requirements. I guess I need to update the slide now that 2016 is coming out, but it began in 2008 and is continued through 2012 and 2014. It does require Enterprise Edition. There's no way around that. It's an enterprise feature, so you must have Enterprise Edition to retrieve that. The next requirement is basically the encryption hierarchy, as we've said. The master database has a master key. The master database has a certificate. The user database then gets a database encryption key specifying an algorithm, and it's stored in the boot record of the database. And then you use alter database and specify the database name, set encryption on. Once you do that, it starts encrypting the database. Now, as soon as you alter the database and set encryption on, doesn't mean that immediately every page in the database is automatically encrypted. It does take time. So if you have a terabyte database, then you are going to wait a while. It's going to be a little bit of time before it encrypts, and so you'll see that I'll show you where to look in the demo of how to tell what state it's in and how much it's encrypted so far, and you can go from there looking until it gets to be 100%. Same concept if you alter database set encryption off. It will then have to decrypt all the pages and store them in the database, and so you'll see a percentage there as well when you decrypt. It'll have the state of decrypting, and it will have the percentage of what completion rate it has on there. So let's talk about the benefits, the disadvantages, and then we'll show how it works in demo. So some of the benefits is that one big one is that you don't have to change anything in the schema. All you have to do is add the encryption hierarchy and then set the data, create the database encryption key, and alter database set encryption on, and now you have an encrypted database. So no schema level changes. It is completely transparent to the user. They don't know that it's encrypted because it's sitting on disk encrypted. Every piece of data that comes up to the buffer pool and goes out to the client is all unencrypted by default, or by virtue of the nature of TDE. Now, the third bullet indicating a degradation of speed. this was published a long time ago, and no one's really republished the article to say how much degradation you get. The reason is because hardware has vastly improved. This was published long before SSD came out, so if you have an SSD SAN or an SSD set of drives, this will not apply in these numbers. The reason I leave it on the slide is for a comparison with TDE compared to cell level. These numbers may not be the way they are, but to compare 3 to 5% as opposed to 20 to 28, those are overheads in what you're going to get in TDE as opposed to cell level. So you can decide what you want to do, but the illustration isn't necessarily just for speed. It is about benefit. So the benefits of TDE could outweigh if you have more data to be encrypted than you have data that you wouldn't want encrypted. You just encrypt the database and be done. In cell level, you have a little more fine-grained control. So the other benefit that can be a benefit / disadvantage is the secure backups by default. When you encrypt your backup, or when you encrypt your database and you back it up, the backup bytes do not go through buffer pools, so they are never decrypted. So the backup streams from the data files and the log files into the backup file, and that means that the data is still encrypted when it hits the backup. So just enabling TDE, boom, your database backups are encrypted now. That can be a good thing. We'll talk about a bad thing here in the next slide as far as how it can be bad. The invisible to the user, that's what TDE is, transparent. And then at-rest encryption is a benefit as well. If someone takes the disk that has the database on it, they're not going to decrypt it without the encryption hierarchy or the OS. I mean, they're just not going to be able to do that. So that's an important piece to remember. And to touch on the disadvantages, this is where the encrypted backups by default come in, and that is that backup compression is no longer effective. If you've ever tried to back up an encrypted or compress a encrypted file, it doesn't compress very well. They're very random characters, and they have very little duplication that is compression friendly. So trying to compress a backup of a TDE database is really fruitless, and the only thing you'll be doing is causing CPU to spike whenever you back up with compression on a TDE database. So if you're going to put TDE in place and think you can use Lightspeed or backup a SQL backup from Redgate or any other tool that you think might squish it more, the only thing you're doing is causing high CPU. That's really all. Some people would say that one of the disadvantages is Enterprise Edition. I think it's kind of an advantage of TDE. If you purchased Enterprise Edition to do TDE, you get a lot of other features too, such as partitioning and other things that you get in Enterprise that you wouldn't get in Standard. So it's kind of a plus, but it is a negative because of cost, and it's been called out. With cell level encryption, you do have finer control because I could just encrypt one column. It does require you to change the schema though. So cell level encryption is an advantage over TDE if you only have 3 or 4 fields in the entire database you want to encrypt, but the challenge is that you now have to change the schema to use var binary, and that could be a problem. Another disadvantage is that when one database is encrypted, TempDB is encrypted for all databases, and the caveat to that is that even if you decrypted all your databases, an instance restart is required to remove encryption from TempDB. So you could call that a very heavy disadvantage if you are using TempDB lightly, or I mean TDE lightly. If it's only for experimentation or something, once you put a TDE database in production, you must restart the instance after you decrypt it to get TempDB to be decrypted. So that's kind of a thing to be aware of. It can be a problem for some people. Backup encryption. We're just going to touch real slightly on this. You can backup encrypt with a certificate or an asymmetric key, but the asymmetric key, if you plan on using that for backup, you must have it in an EKM provider. So you don't get an option to do an asymmetric key backup to encrypt without it being an EKM. So just be aware, EKM solutions, some of them are pretty expensive. You could use Azure Key Vault. The challenge with Azure Key Vault is some organizations don't allow their SQL Server to have access to the internet. So that would be a problem if you tried to get to the Azure Key Vault to use your EKM. The other requirement for backup encryption is you must create a new media set. So if you back up with right-click database backup and use that, you must go into the options and set a new media set. You cannot append to an existing media set and do an encrypted backup. That just won't let you. It'll throw an error, and it won't actually give you the option in the GUI because it knows it's not allowed. The best benefit of backup encryption, if you are not using TDE, is that backup compression is still effective. So what it does is when you back up the database with encryption, it will back up and compress the data and then encrypt it afterwards. So you still get effective backup compression if you do not enable TDE and you intend to use backup encryption inside SQL. So now that's the slides. We do have a couple slides afterwards, but they're basically documentation slides. The rest will sit in the demo. So let's see if we can go into demo. How we doing, Warwick? Everything good so far?
Going great, Chris.
Okay.
Ben, sorry.
Yep. Are there any questions we can take right now, or do you want to wait till later?
I've got a couple of questions, so we can take those now if you want.
Okay.
So, first question, is the same certificate can be used for TDE and SSL?
Yes, it can be. It's just a certificate, so you can reuse or have a certificate you've purchased for SSL and use it in SQL Server as well. Just remember that the more secrets you duplicate, the more vulnerable you can be, right? So that's the only caveat I would say, but you can use the same certificate.
Okay, and the only other question that we've got at the moment is, so because TDE is around encrypting data at rest, wanting to know if encryption of data in motion, say from a web server to an app server, changing from HTTP to HTTPS over SSL, how can we encrypt the data that is being transferred? Is TDE the right solution, or SQL Server by default encrypts data that is in motion?
No. So the encrypting data between clients is actually a multi-protocol thing where you have to enable that. So you would have to create certificates and distribute them to the clients in order for that to happen. Basically, you can think of it like SSL for the client. So just as you grab a browser and go to HTTPS, that encrypts the tunnel between each one because it's a certificate that is installed on the web server that then gets distributed to the client in a public key. So it encrypts, the browser encrypts the traffic. That is not quite the same in concept. By default, you don't have that. So if you were to look at the communications between the server and the client, say a web server is connecting to SQL Server to get data, by default that is not encrypted. You can set up encryption by putting the multi-protocol piece in place and installing certificates at both the web server and on SQL Server to encrypt that traffic just like SSL. It's not very hard anymore to do that, but you would have to do that in order to get it. By virtue of TDE, TDE itself is just encryption at rest, period. Now, in the future, in 2016, they've introduced always encrypted, which is a little bit different in that the encryption is between the client, the web server, and the database server, but the database server data is encrypted by the web server by virtue of the ADO.NET driver. So that is a little different, but it is encrypted between the two. The difference is the data is also encrypted inside SQL, not controlled by SQL, but controlled by the ADO.NET driver. So it is a little different. You'll want to read up on always encrypted. But what your question really is, can you encrypt between the web server and the SQL server? And yes, you can. It is not encrypted by default, and it has nothing to do with TDE. So.
Okay. So one more quick one just before we start on the demo. Can I restore an encrypted backup from a production server to a test or development server if I have the same master key in place for both prod and test servers?
So we will show you, I'll show you that in this demo, how you do that, because on the demo we have we have an instance S1 and an instance S2. And I'm going to show you how to restore from S1 into S2, and you can think of S1 as prod and S2 as test. So yes, you can do it. I'll show you how. It's basically you have to rehydrate the encryption hierarchy on the second server in order to restore. So if you can hang tough for a minute, you'll see it in action actually.
Awesome.
Okay. So in this case, we're going to start on S1, and that is my production server. That's what I call my production server. There is no test TD database here. There are a lot of other databases for my other demos, but there is no test TD database, so nothing behind the scenes. We'll create this database for use. It will be a fairly small database, but it will still serve its purpose for showing TDE. So we'll go into TDE and we'll actually create a table just so we can select it out on the other side. So there's no smoke and mirrors here. And you can see the data is there. So now we're going to back up the database, because one of the most important things to do before you encrypt your database is to back it up. If you don't back up your database and you have issues, you're stuck, because backup is the only way to restore. And if something goes wrong in the middle of encryption, power goes out, the controller for the disk goes out, something goes wrong, and it cannot continue to encrypt because of corruption, you have lost that database and you must drop it. There's no way to fix it. You have to drop that database and then restore from backup and then re-encrypt. So make sure you back up the database in your environment to make sure that you're protected. Now, I want you to pay attention that this master key has a password of instance1 and then password. So I'm going to use master database because the create master key must exist in the master database. I'm encrypting password. The one important thing to remember is that this password is to encrypt the master key, but its only purpose is to open it. If you need to open the master key and you do not have the service master key in place, you need the password. If you have the service master key in place, which typically it is by default of SQL Server starting up, this master key can be opened without the password. So I create this master key and use the instance1 password. And you'll see why that's important. I put these in here for a different purpose. And I'm going to show you the symmetric keys. So the master key is always a symmetric key, and you can see it with a pound. Everything in the database server that has pound in the name of the key or in the name of the certificate is always indicated as a system key. In this case, we have the service master key. It is 256 bits in length. It's AES 256 is the algorithm. That is the default algorithm Microsoft SQL Server uses to encrypt things. The creation date is the date the server was installed. So I installed this version of demo machine way back in 2014, and it retains that. If I modify it, then it will mark a modify date, and that can be modified if I change my service key, my service startup thing, and we'll talk about that in just a moment. But these two keys, Service Master Key and Database Master Key, are now in place. This is the date and time I created the master key, and we're all good. Now I'm going to create my certificate. I'm still in the master database, and I'm going to name it my Database Encryption Certificate, and that's my subject, and my name is my server cert, so that you'll see that in the name of certificate. So I create it. I come and look at the certificates, and sure enough, I see my server certificate, and the private key is encrypted by master key. It's very important to understand. So I have the encryption hierarchy in place because my server certificate is encrypted by my master key. My master key is encrypted by the service master key, so I'm good. Notice the expiry date is 1 year exactly from the date I created it, so it's all good. And notice this key, this field in the certificates view, that is private key last backup date. This is indicating to me that I have not backed up my private key. Now that is bad if I don't, if I lose my certificate and I don't have it backed up. So I'm going to go into TDE right now, and I'm going to create my database encryption key. So we have service, we have master key, we have a server certificate, and now I'm going to create my database master, or my database encryption key with algorithm AES 128, encryption by server certificate. Whenever you see the word server in front of the server and in front of the certificate, it means it's going to look in master. So I'm going to create that. Now notice in here, we'll show you this message, and this is not an error because it's not red, although I believe it should be somewhat red. But if you look at the text, it says, warning, the certificate used for encrypting the database encryption key has not been backed up. So it's warning you that you better keep your backup backed up, or your certificate backed up. So I go back to master because I'm a good DBA, and I want to make sure I back up my certificate. Now this is my certificate name. I back up my certificate to the file equals the CER file, and it can be named whatever you want to name it. But in order to get the entire certificate, I must back up with private key and designate a file and a password. Now the thing to remember is this password is not to protect the certificate. It's to protect the backup of the private key. So the private key is the master guy. That's the one that you want to get. The public key is like, you can distribute the public key anywhere, but the encryption actually happens at the private key level. The public key is strictly to allow people to read it. So I'm going to back that up. And notice out on my file system, I have my certificate, my PVK, and my CER. And now I'm going to look in my view again, and it shows that I have now backed up my private key. So that's imperative to check. If you have a monitoring solution or things like that, that's one thing I would check. Now I can alter database, test TDE, set encryption on. Now we're going to try to catch it in the act. I've put documentation in the TDE SQL file that will be given to Warwick to put up on there, but I'm going to show how to see whether it's encrypting or not. So I'm going to alter database and set encryption on. We did catch it, but we caught it early. So apparently my machine's running faster than normal, and test TDE is my database. Is encrypted is set to 1. 2 is the status, and as we look up here in the statuses, 2 equals encryption in progress. Now notice tempdb is set is encrypted equals 0. Now the state is 3, which equals encrypted. So just know that in the system database, at least in 2014 and below, tempdb says is encrypted equals 0, but yet the state is 3. We've noticed that that has changed in 2016. They've actually made it say 1. So I'm not sure why, but just know that in 2008 through 2014, you won't see is encrypted equals 1 on tempdb, but you will see an encryption state of 3. In 2016, you'll see encryption state 3 and is encrypted 1 on tempdb. So it's a change that I guess they felt like they needed to make. But in the encryption state, here's the query. It's in the DM, and that's where you see the percent complete and the encryption state is in the SysDM database encryption keys view that you can join with the sys databases on the ID. So now we have the other thing I'll illustrate too is that in the view of sys databases, you'll see this guy. This is sys databases view right here. The create date is actually in local time. But in DM encryption database encryption keys, all the things pertaining to encryption in the database as far as create date are all in GMT. So just know that GMT is involved when you use the DM in database encryption keys view, or DMV. So now I'm going to back up my database after it's been encrypted. And now we're going to switch to instance 2. Now instance 2 doesn't have anything in the hierarchy put in place. So if I were to restore file list only from my backup, it would say I can't. So the cannot find server certificate with thumbprint of this, it is looking for that, and therefore file list terminates. So let's get it back in place. So I use my master database in S2. I create my master key. Now notice I've used a different password. There's 2 ways you can create a master key, one with a password or one from a backup of a master key. So I could actually go back to S1, back up my master key, and then restore my master key inside this instance, and it would then encrypt by service master, and it would be fine. You don't have to do that, and I'll show you that you don't have to do that by creating one with a different password. And it's a different key because it has nothing to do with S1. So it's a new key. This is where the critical nature is if I do a different master key, that's really not important because it's up the hierarchy. This certificate is what is critical in encrypting the database encryption key. So this does have to be the same. So I create certificate, I name it whatever I name it. I don't have to name it the same either. From file, I specify my public key, my private key, and my password. I specified the password, my private key. If I restore that, then I then go and look and make sure that I see my encrypted by master key, and I don't have a private key because I just restored it. I don't have a, but now I can go restore file list only, and now I see my data. So I could actually restore my database, use test TDE, and select from the table, and I have data. So the way you create things back in place is you must recreate the hierarchy from master key all the way to the certificate, and then you're allowed to restore the database or see what the contents of that database. So if that helps, the question that says, can I restore from prod to test? Yes, you can, as long as you have this guy. You need to have the certificate to decrypt the boot record key, that the database encryption key. If you don't have that, then you won't be able to do that. One other note is those of you who are still back on SQL 2008 or 2008 R2, you used to be allowed to drop the master key and drop the certificate. But they fixed it in 2008 R2 SP2. They now put a dependency on here so you cannot drop an artifact that is encrypting something up the chain. So you can see that I cannot drop the certificate because it is bound to one or more database encryption keys. And I can't drop the master because it is encrypting the My Server Cert certificate. So it knows about the dependencies now to keep you from blowing up. What will happen prior to SP2 in 2008 R2, you could drop the certificate and the database would be fine as long as the instance was not restarted or the database was not taken offline and brought back online. So you would be safe until such time as you would then restart or do whatever, and the database would have to be reloaded. It would then no longer load. So if that helps. Now the last thing I'm going to show in demo is I create a database called MS SQL Tips. No relation to the site, but just I guess it already exists. I better drop it because otherwise the demo won't work. Oops, and now I got to get out of this. this database or else it won't drop. Yeah, so let's drop it again. There we go. All right, so now it's gone. No MS SQL tips. We'll create the database, and we'll use the database there. I'm just going to run this file. I'm going to include it in the demos so that you can play with it yourself, but basically it creates a symmetric key and it creates an asymmetric key. One with an algorithm of AES-256 because it's a symmetric key. You can't use higher encryptions, and RSA 512 is the lowest key you can create. So I used the highest symmetric and the lowest asymmetric to kind of get close to apples, which I'm not. So I'm using an apple and an orange. But the demo will demonstrate the execution of an encrypted column. So there's two tables that are created, and I insert some data in there, 5,000 rows. Okay, so if I execute it, we'll let it run really fast, and when it gets done, right now it's done. 5,000 rows. The symmetric key time it took is 293 milliseconds. And the time it took for the asymmetric key is 2493. So 293 milliseconds compared to 2.5 seconds. So just from that alone, you can see the difference in speed. The workload's going to depend, but that was just a real quick, hopefully apple to orange comparison to show you how fast or how slow each key type is when you use them. So that'll be included in the demo scripts that you can play around with. Hopefully that helped illustrate that, and we'll go back and just finish up the slides. And then we'll take questions. So I left in here some DMVs that you're going to use for encryption, the key encryptions, the symmetric keys, the certificates, the DM encryption keys for the database, and the asymmetric keys views. Things to watch for. Make sure you back up your database before enabling TDE. That's just part of being a DBA. And then we already talked about the certificate being able to be dropped in the hierarchy prior to SP2. Back up all certificates and private keys as well. Treat them like databases or data that you want to keep safe. The other thing to note is that when you mirror or use replication and you have TDE enabled, both databases are encrypted. Mirroring, you must restore a database backup and a log backup. Same with always on, availability groups. They must be also primed with a database backup and a log backup, which means they're both encrypted. So just know that once you encrypt the database on the primary, the database is going to be encrypted on the secondary. That's just part of the deal. Ticking time bombs really aren't relevant today. If you're going to put 2012, 2014 enabled on a database, or 2016, you can no longer drop the certificates or artifacts that you need to keep in place. So don't worry about the ticking time bombs unless you decide you're going to do something prior to SP2. Only available in Enterprise Edition. TD is enabled via keys and certificates. Remember, it's at rest, not over the wire or not in RAM, so your data is not completely protected except for theft of the drives or the data files or the backups. Those are all protected. Backups of encrypted databases are encrypted by virtue of the fact that it is not decrypted before it backs it up, and make sure you protect your assets. So hopefully you get to your SQL Saturday in your area. SQL Pass has a lot more to offer. This is one of the virtual chapters. There's many other virtual chapters. If you go to SQLpass.org/virtual chapters, I believe is where it is. There's tons of chapters. Look for user groups in your area. There are great resources to network, get to know people in your area, and there's plenty of other things out there for resources as well. Hopefully that was informative and helpful. If you have any questions, my inbox is always open. I blog at dbaduck.com and also PowerShell DBA. I do a lot of PowerShell and database stuff. So with that, I'll take questions and we can wrap it up.
All right. Thanks, Ben. So I have a question around when do we enable TDE on mirroring databases? Before mirroring setup or after mirroring setup?
Before.
Before. Okay.
Yeah, if you try to enable it afterwards, it will fail unless you have the encryption hierarchy installed on the other side. So it is best practice to do TDE before you mirror.
Staying on the HA stream of things, you mentioned before that with availability groups that you need to set up the TDE and have the encryption on the primary and the replicas to be able to do the restore like you showed in the demo. What about with the impending release in 2016 if you were configuring your availability group to use the auto seed function? Will it break or will you be able to do it after the fact?
That is a really good question. I have not tried that yet, so I would conjecture that the auto seed would still need the encryption hierarchy because that's how TD works. You would have to have the encryption hierarchy on the other side because auto seed should only bring the database itself over to the other side, not the master with the certificate and the master key. That's the pieces that you'll miss, is that it does not affect the master database. So you would need to have that in place. I'm actually going to go play with that this week now that you mentioned that, just to make sure I know all the steps to do that. But auto seed is all about you not having to do it yourself. Kind of like replication where you can do a snapshot and it will actually push the snapshot over to the other side without you having to back up and restore. But I believe you still have to have the encryption hierarchy in place on the other side.
All right. If we've got no other questions, then I would like to say thank you to everybody for attending this session. I'd like to say a big thank you to Ben for his time in spending with us and teaching us about SQL Server Encryption. So I would like to say thanks once again and hopefully get to see all of you again next month, where we've got Danny Cherry talking about SQL Server Database Administration for the non-DBA.
Thanks, everyone. Have a great night or day for you guys. I'm going to go to bed.
Thanks, Ben.
Yep.